For this section, we're going to talk about trigonometric values of special angles. So special angles ties into these two special triangles. The first one we're going to talk about is the 30, 60, 90 degrees triangle. So this is what I mean by special angle. So a triangle that has 30 degrees, 60 degrees, and 90 degrees. So here's a picture of the triangle where the angles are labeled 90 degrees, 60, and 30. And then on the sides are the known side for this particular triangle. And what I'm going to do is I'm going to use Pythagorean theorem to show you why we have those sides labeled and why we're always going to use those numbers whenever you have a 30, 60, 90 degrees triangle. So again, we're using the Pythagorean theorem. So whenever you have a 30, 60, 90 degrees triangle, you always have one side that's always going to be 1 or equivalent to 1. And then you're going to have the longer side where it's going to equal to the square root of 3 or equivalent to 3, square root of 3. And then the hypotenuse is 2 or equivalent to 2. So to review, to refresh, Pythagorean theorem is always a squared plus b squared equals c squared. Now I'm going to do the work here just to show you why we have these numbers and how they are connected to each other with these angles. So a squared is always the shortest side, which is 1. So I'm going to write 1 squared plus, and then b is usually the longer side than the shorter side. So this one's square root of 3 square equal, and then c squared is the hypotenuse, but I'm not going to put in the value yet. I will show you why we get that value. Alright, so 1 square is just 1. Now I'm going to show you the work for the square root of 3 square. So when you have the square root of 3 square, it just, again, means the square root of 3 times the square root of 3. And I'm going to include parentheses because we have multiple operations. So inside my parentheses, we have square root of 3 times square root of 3, which is the square root of 9. Now once I multiply inside, I can get rid of the parenthesis. Then continue to simplify. The square root of 9 is 3. Then I'll add 1 plus 3, which is 4, equal c squared. Now if I want to get c by itself, then I got to do the opposite of square. So the opposite of square for c squared is the square root. And again, if I square root on the right side, I have to do it on the left side. So the square root of c squared is c. And then the square root of 4 is positive and negative 4. I mean 2. So c equals positive 2 and negative 2. But when we're doing with length of a shape of a object, we always use positive number. So c equals to 2. Now that's why the hypotenuse is 2. So whenever you have a 30, 60, 90 degrees triangle, then you already know the length of the sides. 1, square root of 3, and 2. But say we have a similar triangle of same angle measure but different side lengths. So say we have another triangle. Same angles, still 30 degrees, 90, and 60 degrees. So what happens if I decide to multiply each side by 4? So if I do that, then this side will be 4. This 4 times square root of 3 is just simply 4 square root of 3. When we're working with radical numbers, they can act like variables. So it's just like x times 4 is 4x, square root of 3 times 4 is 4 square root of 3, and then 4 times 2 is 8 up here. Now if I were to do the Pythagorean theorem, so again, a squared plus b squared equals c squared. So my a squared, the short side, 4 squared. Then my longer side is 4 square root of 3 squared equals c squared. 4 squared is 16. Now I'm going to write out the steps for this since we have a number with a radical. So 4 square root of 3 times 4 square root of 3 equals c squared. Alright, so I'm going to write over here to have more room. So 16 plus, now here when I'm multiplying, I'll multiply the whole number that's outside the radical, so 4 times 4 is 16. And then I'm doing this step by step, so the inside of the radical, so 3 times 3 with the square root equals c squared. And then I bring down the first number, 16, and then I bring down the 16 here because we still have to do the square root of 3 times 3, which is 9, equals c squared. And then again, 16 plus 16 again. The square root of 9 is 3, but I put in parentheses because it's multiplying. Multiplying there, multiplying there, multiplying inside here and here. Equals c squared. And then 16 plus 16 times 3 is 48 equals c squared. And then I'm going to write on the side here 16 plus 48, well, that's going to be 64. So let me write a different color. 64 equal c squared. So let's review. Using the Pythagorean theorem, I use the sides from this triangle, 4 squared plus 4 square root of 3 squared equals c squared. We already know how we got 16 from that 4 square. And then here I'm doing step by step. So 4 square root of 3 square means 4 square root of 3 times 4 square root of 3. And I bring the work over here. So the 16 stays the same, nothing to do. And then from here we multiply the whole number, so 4 times 4 is why we got 16, and then I combine the square root of 3 together, so now it's square root of 3 times 3, which leads to 16 square root of 9, which leads to 16 times 3, and then it leads to 48. And when we do 16 plus 48, it's 64 equals c squared. So if we were to do that again, so I'm going to write right here, so 64 equals c squared. And if I want to get c by itself, I do the opposite of square, which is square root. Since I did it on the right, I got to do it on the left. So the square root of c squared, again, will be just c, since it's a variable. But for numbers, the square root of 64 is going to be positive, negative 8, but we're always going to use a positive number when we're dealing with lengths. So C equals positive 8. So there is a pattern, there is a relationship, and I proved it using the Pythagorean theorem. So since I multiply all sides of this triangle by 4, then I could say that if I were to multiply this by 5, then using Pythagorean theorem, I can still prove that all the sides are connected. If I were to do it times 12, using the Pythagorean theorem, you would get the same process, similar results, that the sides are connected because of the special angle, 30 degrees, 60 degrees, and 90 degrees. So typically, for this type of triangle, you would mostly see a picture of this triangle, which I'm going to show you. So whenever you see a 30 degrees, 60 degrees, and 90 degrees triangle, typically you're going to see the sides. It won't just be numbers, it'd be x, the square root of 3 times x, and then 2 times x. So from here, if I were to multiply the one in black, say multiply by 7, 1 times 7 would be 7, so 7 in here. Square root of 3 times 7 would be square root of 3 times 7, 7 square root of 3. And then 7 times 2 would be 14, so here would be 14. So if x equals 7, then our triangle, the 30, 60, 90 degrees triangle, here's my x, so that would just be 7. 2 times x, so 2 times 7 is 14. And then square root of 3 times 7, so let me write it out, will be just 7 square root of 3. Just like how we did the picture for when we multiply all sides by 4. This is the length of the triangle, and then when you use Pythagorean theorem, you will see that 7 square root of 3 is going to be connected to the 4. So this is the triangle that you will normally see when dealing with 30, 60, 90 degrees triangle. With the second triangle with special angles, this one is the 45, 45, 90 degrees triangle. So in the event you have a triangle where both angle is 45 degrees and the last one is 90 degrees, then you will see that the two sides of the triangle will be the same and the hypotenuse is square root of 2. And then I'm going to show you how those numbers are connected with the Pythagorean theorem. A squared plus b squared equals c squared. Now since the two sides are the same and the numbers are the same, doesn't matter what numbers and which place you put in. So I'm going to put 1 square, and then for the other one, I say I'm using the second one, so 1 square equals c square. So 1 square is 1 plus 1 square is another 1 equals c square. We do 1 plus 1, which is 2, equals c square. So over here, with some more room, so when I'm trying to get c by itself, I need to do the opposite of the square, which is square root. Since I did it on the right side, I gotta do it on the left side. So the square root of c squared on the right is just c. The square root of 2 is plus or minus 2. But whenever we're dealing with length of a shape, object, we always use positive. So square root of 2 is c. That's why we have square root of 2 for the hypotenuse. So if I were to draw another triangle with the same angles, so I will show you that there is a pattern. So say I multiply all the sides by 3. So again, I'm multiplying all the sides of the triangle by 3. So therefore, we're going to have another triangle. It's going to be the same angle measurements. So 45 here, 45 there, and 90. So 1 times 3 is 3. 1 times 3 is another 3. 3 times square root of 2 is 3 square root of 2. So, again, I'm going to prove that sides measurements are connected by using the Pythagorean theorem. So, a squared plus b squared equals c squared. So, I'm using this 3 for the a, plus I'm using the second one for the b. So 3 squared plus 3 squared equals c squared. So 3 squared is 9, plus 3 squared is another 9, equals c squared. So 9 plus 9 is 18, equals c squared. Now, we're going to simplify this. Again, we want to get c by itself. The opposite of square is square root. And I do it on both sides. So here is going to be a plus or minus square root of 18 equals c. Now, again, we're dealing with the measurements, lengths, so we want to use positive. So square root of 18 equals c. But we're not finished. Here, we can actually simplify, continue to simplify. So I'm going to write it over here. So in any event, you can break it down further. What we're going to do is we're going to break it down into factors where one of them can square root. So here, 18 is not a perfect square, so you can't automatically square root into a whole number. But we can break it down into two numbers. So for example, we could break it down into 9 and 2. But we still have the square root. So again, the square root of 18 is the same thing as square root of 9 times 2. Since these two numbers are inside and it's multiplying, we can split into 2. So square root of 9 times square root of 2. And then one of them, which is this, you can actually do the square root, which is 3. And I bring down the square root of 2. So 3 times square root of 2 is just 3 square root of 2. So therefore, the square root of 18 will simplify into 3 square root of 2, which is c. So we can see that the sides are connected. Now, say I want to do another example with different side measurements. And again, I'm still going to use the Pythagorean theorem to prove the sides are connected. So instead of multiplying by 3, let's say we try a smaller number but different one, 5. So 45 here, 45 there, 90. 1 times 5 is 5. The other one, 1 times 5 is also 5. 5 times square root of 2 is just 5 square root of 2. So again, Pythagorean theorem, I'll use the first 5. So 5 square. The second 5 square equals c square. 5 squared is 25. Another 5 squared is also 25. Bring down to c square. And then 25 plus 25 will be 50 equals c squared. Bring it over here for more room. So again, get c by itself, so we do the opposite of square. So square root on both sides. So now we have plus or minus square root of 50 equals c, but we always use just a positive. So square root of 50. Now, 50 is not a perfect square, so you can't just do the square root of it right away. What we can do, we can simplify. So I'm going to bring it over here, the square root of 50. We can break it down into two factors, two numbers, but one of them has to be a perfect square. So let's use 25 and 2. Now the reason I'm using those two numbers is because one of them is a perfect square. So since we have two numbers and it's multiplying inside the square root, we can split it into two square roots. So square root of 25 times square root of 2. Now if we look, this one right here, you can do simplify. So the square root of 25 is just 5. Bring down square root of 2, so it's 5 times square root of 2, which is 5 square root of 2. So now I'm going to bring it over here. So the square root of 50 will simplify to 5 square root of 2 equals c. And see we that it match. So there is a pattern. So when you have a 45, 45, 90 degrees triangle, then the two sides are the same. And if two sides are the same, then it's basically just a number in front of the square root. So the formula or the rule for a 45, 45, 90 degree triangle is pretty simple. Which is the rule for it. And again, it has to be two angles, both 45. And the last one is the right angle, 90 degrees. So if one side is x, the other side is also x. And in here, whatever x is going to multiply to the square root of 2. So square root of 2 x. So that is the rule you have to remember for the 45, 45, 90 degrees triangle. In the event you see one based on the angles 45, 45, then you can tell that these two sides will always be the same, and whatever the size is, just multiply to the square root of 2. Now the reason I went over those two triangles with special angles is that there's going to be a pattern when you are trying to find the degrees, the angle, when it comes to sine, cosine, tangent, cosecant, secant, and cotangent. Now here you see a chart of the angles for these two triangles only, these two types of triangles, the 45, 45, 90, and the 30, 60, 90. So on this chart, you have our angle and each trig function, sine, cosine, tangent, cosecant, secant, and cotangent. So whenever they ask you for like the trig function and specify which angle, so when it's for sine, 30 degrees is 1/2, 45 degrees is the square root of 2 over 2, and when it is 60 degrees, it's square root of 3 over 2. For cosine, when it's 30 degrees, it's square root of 3 over 2. 45 degrees, square root of 2 over 2, and then 60 degrees, 1/2. Tangent, it would be square root of 3 over 3 for 30 degrees. 45 degrees is just 1. And then 60 degrees is just square root of 3. Cosecant theta is for 30 degrees 2, for 45 degrees square root of 2, for 60 degrees it's 2 square root of 3 over 3. Secant theta, when it's asking for 30 degrees, it will be 2 square root of 3 over 3. When it's 45 degrees, it's square root of 2. And when it's 60 degrees, it's just 2. Cotangent theta, when it's 30 degrees, it will be square root of 3. When it's 45 degrees, it's just 1. And for 60 degrees, it will be square root of 3 over 3. Now later on, you will see how all of them are connected when it comes to the unit circle, especially when you're trying to find sine, cosine of a given angle. So best recommendation is to copy down this chart and memorize it, but I would highly recommend just basically sine, cosine, and tangent, because those are the three most important basic trig functions. And later on, you're going to remember that sine is going to be related to cosecant, cosine is related to secant, and tangent is going to relate to cotangent. Once you know the exact values for each trig function for each angle, then you'll be able to find the rest of the 9 exact values for cosecant, secant, and cotangent.